presenter is PhD student Melissa Ozzi. She's at the Institut de Recherche sur la biologie de l'insecte in Tours. And Melissa, if you want to take away.
Yes. So, hello. Here we study the nest chemical signatures of the invasive Asian hornet. We found that nest structures present the same hydrocarbon composed as the cuticle of hornet. We observe quantitative and qualitative different chemical profiles. So what have we done? We did hydrocarbon extractions on envelopes, combs, and pillars for each of the 10 nests. Then we look at the chemical distances between interstructures, intercolonies, and intrastructures. We found that nests present a specific colonial signature. The chemical heterogeneity observed in structure confirms the chemical heterogeneity previously finding in the French population, but we do not know how hornets mark the nest, if it's passive or active. Thank you.
Thank you very much. Now we'll keep all the questions, I guess, for the breakout room. The second poster presenter is master student Anna Cuesta. She's at Copenhagen. Do you want to take away, Anna?
Yes. Hi, my name is Anna Cuesta, and I'm developing my master thesis in the sensitivity of the honeybee gut microbiota to pesticides. The honeybee gut microbiota is a quite simple community that is constantly exposed to pesticides, and it's already been proven that it can be affected by them. So to test this out, what I did was an in vitro experiment where I exposed the 8 co-members of the honeybee gut microbiota to 4 commonly used pesticides, and I could see that they were only affected by the presence of oxalic acid, and more interestingly, there were some species that were more sensitive than others. And I also performed an in vivo experiment where I exposed the bees directly to these compounds, and then I analyzed their gut communities. What I could see was also that these compounds, that the communities that were more changed were also the ones that were treated with oxalic acid. Thank you for listening to me, and if there's any further questions, please join me in the breakout rooms later. Thank you.
Thank you, Anna. That's great. Poster presenter is Dr. Daniel Schlappi. He's a postdoc at the University of Bristol. Take it away, Daniel.
Hi, everyone. Well, agrochemicals and pathogens are important drivers of insect declines. And in this study, we looked at effects of a neonicotinoid and acute bee paralysis virus on Lasius niger. Our results suggest that the 2 stressors have antagonistic adverse effects on colony development. For that, we performed a long-term experiment over 64 weeks with thiamethoxam exposure and a feeding regime with ABPV-infected honeybee pupa. We conclude that a holistic understanding of stressors needs to incorporate stressor interactions, acute and long-term effects, multiple effects levels, and fitness as the ultimate response variable of choice. Thank you very much, and see you in breakout rooms.
Indeed, thank you very much, Daniel. Our 5th poster presenter is Dr. Thomas Parmentier from University of Namur. He's a postdoc there. You can take it away, Thomas.
Hi, I'm Thomas. So I work on myrmecophiles. So myrmecophiles are arthropods that live in ant nests, and they are typically found inside the nest, and there are only a few records of them outside nests. And so there's almost nothing known about their dispersal or their mobility. And I tested their mobility outside the nest using pitfalls in a community of associates or guests associated with red hood ants. And I found really a massive number of them outside the nest. So this suggests that they are much more mobile than currently predicted. And moreover, they do not move randomly, but they really follow the trails of the ants. I have much more to say about myrmecophiles and their mobility, but that can be discussed in the breakout rooms.
Thank you very much indeed. There's plenty of time for this, so I urge everyone who can stick around to make the day of all the poster presenters and go and visit the breakout room. Our last poster presenter is PhD student Suzanne Smith from the University of Copenhagen. Do you want to take it away, Suzanne?
Yes, hello.
Yeah.
My poster is about how the fungus farming termite symbiosis might use natural products to avoid diseases. Through extensive literary research, natural products have been discovered in all members of this symbiosis. Their key characteristics were summarized along with all reported antimicrobial activities linked to each individual compound. We analyzed and discussed the potential for interaction between complex compound mixtures and how these might potentiate the antimicrobial activity. When looking at our comprehensive list of compounds already identified, we know that this symbiosis has outstanding opportunities. For one, only a fraction of the species have received any chemical analysis, and previous studies have only investigated the antimicrobial potential of the natural crop products individual, and combination of compounds could unravel new information of the symbiosis defense barrier. This review highlights the antimicrobial activities are present in all partners of the symbiosis, and show that we are only at the beginning of investigating the chemical potential.